We're on problem 15. It asks us if triangle ABC and triangle XYZ are two triangles such that, okay, let me draw these two triangles. So triangle ABC, maybe it looks something like that. ABC, and then we have triangle XYZ, and we want to prove that they're similar. So similar means that they look the same. They have a similar shape. They could be of different sizes. So essentially, all of their angles are the same, or all the ratios of their sides are the same. So XYZ might just be a smaller version. Maybe I should run a bigger one. XYZ. It looks like they want us to prove the triangles are similar. They tell us that the ratio of AB to XY, let me color that. They say the ratio of AB to XY is equal to the ratio of BC to YZ. Is equal to the ratio of BC to YZ. Which of the following would be sufficient to prove the triangles are similar? So there's a couple of times when you know that a triangle is similar. Is if the ratio of all of the sides are equal. Ratio of all sides. Think about it, just giving two sides isn't enough, because even though I drew them so that they're similar, it could look something like this. Maybe the ratio here is, I don't know, 2 to 1. So maybe AB and XY, maybe that's a 2 to 1. Maybe that's 2, and that's 1 like that, right? The ratio is 2 to 1. And maybe BC to YZ is also 2 to 1. But why? There's nothing that tells us that that can't open up like this. It could be like a 2 and a 1 ratio, right? Or actually, even better, I don't want to draw them similar anymore. I want to draw them unsimilar. Maybe BC comes in like that. Maybe YZ goes out like that. And so just knowing that the ratio of two of the triangles are two of the sides are the same, that alone doesn't tell you that you're dealing with a similar triangle. These two triangles would be very different, right? These are definitely not similar triangles. In fact, all of the angles would be different. Now, how do you prove that something is similar? Well, I attempted this problem about 2 minutes ago, and it stumped me because I think, if I'm right, that there's a mistake in the problem. In geometry class, they always teach you that if you know that the ratio of two of the sides are equal and that the angle between them are equal, then that's sufficient to say that it's a similar triangle, or that you can make the conclusion that the ratio of AC to XZ would also be equal. So that's the answer they're probably looking for. That if you have the ratio of AB to XY, you have the ratio of BC to YZ, then you want the angle in between them to say, okay, these are similar triangles. So you'd have to know that angle B is congruent to angle Y. And then that is choice B. Now, I don't argue with the fact that angle B being congruent to angle Y is sufficient to prove that these triangles are similar. I just think that some of these other things are actually sufficient to prove the triangles are similar. Then they don't teach you the tools in geometry, but you can even think about it intuitively. I mean, once you learn the law of cosines and in trigonometry, which you're not that far away from right now, you'll see that any of the other angles, if you know that the corresponding angles are congruent, you would be all set to know that these are going to be similar triangles. So if you know that for example, if you know that angle C is congruent to angle Z, and you could even think about it. Let's say if you knew that angle C was congruent to angle Z, there is no other way to draw this triangle versus just having a similar triangle. So example, see in this one right here, this would be angle C, and this would be angle Z. And clearly these two aren't congruent. If you think about it, when you say that this angle is congruent to this angle, you're constraining the shape of this line right here. You're constraining the direction that it goes in, right? You're constraining the direction it goes in. If you forced this angle to be the same as, let's say that you said this angle is equal to that angle, then you would have to go out in this direction out there. And then you would break what you originally said, that the ratio of that to that is equal. So just think about it in terms of when you add another angle, it actually does constrain the triangle to being similar. And the same thing is true, angle A and angle X. If you know that angle A is congruent to angle X, that also constrains the triangle to being similar. The only one that I know definitely isn't sufficient is angle X being congruent to angle Y. That's useless. These two angles, that just tells you that there's some type of an isosceles. Let's see, angle X congruent to angle y. Yeah, that doesn't help you. I mean, that tells you that this one is an isosceles triangle because you have these two base angles would be the same. So that would be the same as that, but it doesn't tell you anything about how does this relate to that. So even though the answer they're looking for is probably B, I would say that A and C are also sufficient. Next question. Question 16. And send me a note if you think I'm missing something. Because I've thought about it a little bit. All right, 16. 16. In parallelogram FGHI, let me draw a parallelogram FGHI. We have one side, and let's see, we come down at a 45-degree angle. We have the other side. Then let's say we go up at a 45-degree angle. I can do it from here. Close enough. Got my parallelogram. Parallelogram FGHI. So that's F, that's a G, that's an H, and that's an I. Diagonals IG and FH are drawn and intersect at point M. So let me draw IG and FH. Okay, these are lines. IG and FH. Fair enough. And they intersect at point M. They intersect at point M. Which of the following statements must be true? Okay. See, triangle FGI must be an obtuse triangle. Triangle FGI must be an obtuse triangle. And that means that one of the angles in the triangle is more than 90 degrees. I mean, just the way I drew it here, which is a completely legitimate way to draw it, all of these lines are parallel, we see that that doesn't have to be the case because just the way I drew it, all of these angles are less than 90 degrees. So that's definitely not the case. Triangle HIG must be an acute triangle. Triangle HIG must be an acute triangle. HIG must be an acute triangle. So let's think about it a little bit. Let's try to prove it by contradiction. Let's say that one of the sides was more than 90 degrees. So this is just the way I happen to draw it right here. But if you think about it, I could have drawn it like this. So the way I drew it, HIG is an acute triangle. All of these sides are less than 90 degrees. But I could have drawn this the complete opposite way. Let me draw it that way actually. I'll do it quick and dirty. So what if I drew it like this? What if I drew our parallelogram like this? Right? The direction that I drew it in was arbitrary. So now this is F, G, H, and I. And they're talking about triangle HIG. Right? Well, clearly in this case, angle H right here, this is an obtuse angle, right? That is greater than 90 degrees. So there's nothing, and so HIG would be an obtuse triangle. So there's nothing that prevents us from drawing the parallelogram like this, which would make this an obtuse triangle. So that triangle does not have to be an acute triangle, so B doesn't work. All right, what else do they say? Triangle FMG, that's FMG, must be congruent to triangle HMG. Well, that's congruent. So that would mean that all the sides are equal and everything. And that's clearly not true. I mean, they share this side right here, but this side up here could be a lot longer than that side, which would make this side here a lot longer than that side. So that's definitely not true. So D is probably the answer, but let's see if we can prove it. Triangle GMH must be congruent to IMF. So let me do that in two different colors. So GMH, that's that one right there, must be congruent to IMF. Must be congruent to IMF. That's that one right there. Let's see. First of all, we know that this angle and that angle are going to be congruent. They're opposite angles, or as they say, vertical angles. The reason I don't like using vertical angles is because this angle and this angle are also opposite angles, and to call them vertical angles is bizarre because they're not vertical with each other. Anyway, that's just my problem with the notation. Okay. All right. Okay, so where were we? We wanted to prove that that triangle are congruent. This angle is definitely equal to that angle. And we know that this line is parallel to this line, right? So we could view each of these crossing lines as transversals between two parallel lines, right? That's a parallel line, that's a parallel line. So if this is a transversal between two parallel lines, then this angle is going to be congruent to that angle. And that's because I think the word is opposite internal or alternate interior angles or something like that. And it makes sense. You could imagine drawing the transversal either way, and then the angles would change, but they're always going to be congruent. And by the same argument, this angle is going to be congruent to that angle. So we know that all of the angles are the same, and now we have to make some type of argument that, well, all of the sides are the same. Really, if we could just prove that one of the sides are the same, then we know that all of the sides are the same. Well, we know that it's a parallelogram. It's a parallelogram. So in order for all of the sides to be parallel, the opposite sides have to be the same length. And I'll leave you to think about why that is. But if all the sides are the same, or the opposite sides are the same length, we know that this side is equivalent to this side. So, we could use one of those geometry postulates that they, angle, side, angle, right? We have an angle, a side, and an angle, a side, and an angle. Say, okay, that's enough for us to show that this is congruent. These are congruent triangles. So the answer is D. Anyway, see you in the next video.